Welcome students. Today we will discuss about depth first full search algorithm. This algorithm is mainly used for optimization problems. So we have already discussed what is optimization. Optimization is a process of finding the best value x star for which the objective function f of x, it takes either minimum or maximum, min or max. So you have to find out the best value x star for which the f of x is either minimum value or maximum value. That is optimization problem. So let us see what is the working principle of depth first full search algorithm. What is the working principle? So in this depth first full search algorithm, we will access all the variables one by one. Correspondingly, its values are taken and framed to the solution. This process is repeated until you reach the last variable. Once you reach the last variable, you frame the solution and then you evaluate it. After that, you perform the backtracking operation and then you reach the remaining nodes and again you frame the solution, you evaluate. This process is repeated until all the solution space is traversed. Okay, so let me explain this process with the help of the diagrammatic manner so that you will understand in a easy way. Say for example, you are having three variables. Capital X is equal to small x1, small x2, small x3. Let us suppose x1, x2, x3 are all binary variables. That means it can take either 0 or 1. So with this DFS algorithm, you take the nodes as the variables x1 and its corresponding edges as the values. So x1 can take either 0 and 1. So at the next level, you will have the x2 variable. The nodes present in the second level, it takes another variable. So this is level 1. At second level, you will have the second variable. So the edges connected to x2, it can take either 0, 1. Similarly here also x2 can take 0, 1, and then at the level 3 you will have the third variable x3. Similarly here also x3. So this is level 3. It can take 0, 1. Similarly 0 and 1. This can take 0, 1. 0, 1. So what you have to do means, you need to traverse from root node to the leaf node. Here the leaf node corresponds to the solution. You can see the first traverse path, you visit one variable, that means first visit node, and then you take the first value, that means you have to traverse in this direction. So again you visit the x2 variable, and you will observe that x2 variable also can take 0 or 1, but again you take the first value, and see you reach another variable x3. So since it is x3, again you have to take the first value. By this time there are no variables are there, so you can conclude that you have reached the leaf node. So thereby whatever the path you have traversed, basing on that you can frame the solution as, the first solution as 0 0 0, okay, 0 0 0. Similarly, after framing this solution, you apply the evaluated function. Let us suppose this is x1 solution, corresponding to x1 solution you compute f1. So after computing the f1, you again perform the backtracking. So here x3 again it can take 1. So again it can take, you can have values 0 0 1. Similarly, you can go in this direction, you will get 0 1 0, and this solution has 0 1 1. You can please draw it. I will draw for you. This is x3, and it can take either 0 or 1. Correspondingly it can take 1 0 0. This is 1 0 1, and this is 1 1 0, and this is 1 1 1. So with the help of traversing the path, you can generate so many number of intermediate solutions. Let us suppose x2, corresponding to x2 you will get the f2, this is x3, you will get f3, and again this is x4, you will get f4, like this. Here you can have 8 solutions. So you will have f8, okay. So each time you are getting a solution, you compute immediately the f1, its evaluated value. When you are computing the next solution, you have to make a comparison if it is better than the previous one, okay. So that means say for example, in this way you generate x1, x1, x2, x3 and so on, okay. So at first iteration, if you generate f1, you make it as a best solution, okay, you store it here. When you generate x2 solution, you compute f2, and then you compare with this, that means you perform the comparison of f1 and f2, store the best in this, okay, parameter. Likewise, each time you generate a solution, compute its evaluation value f3, f4, and then compare with the previous evaluated values and store the best in this solution, okay, in this parameter. This is how you will evaluate the performance or generate different intermediate solutions and find the best value. This is how the depth first full search algorithm works. Okay. So what you need to understand is, in depth first full search you will have a tree like structure where you will have nodes and edges, and each node corresponds to the variable and edge corresponds to the values taken by that variable. Okay. So while you are generating or traversing the path from root node to the leaf node, you will get one intermediate solution. For that solution you store that result. Okay, you store that result, and then when you are generating new intermediate solutions, make a comparison with the previous best solution and then store the best one. Make a comparison and store the best one. Okay, this is how the algorithm works. After traversing all the paths, you will get the best solution. Okay, so after understanding this, now we will go to the algorithm. So how this algorithm is constructed. So depth full search algorithm, DFS. Okay, let us see the algorithm here one by one. I will write a simple set of steps so that you will have a better understanding. So let us identify what are the inputs for this and what is the output. So the input for this algorithm is, you have to specify the level level of the tree. Actually this is implemented with the help of recursive manner, and then B is the branch, or you can say as a index. Okay, index of the tree, and then the domain. What is the domain? So actually it is a vector list. Okay, it is a vector. Okay, it is a vector list. Vector list of size capital D dimension with domain values. So let us see, and the function is equal to the evaluated function. You have to specify the type, that means whether we want to find out the min or maximum, and if required you can specify the dimension also. Dimension of the solution means number of variables in simple. Okay, dimension. Okay, I will write. Finally, the current solution vector. So what is the output? So you will get the output as a list of containing the solution, or you can say as a optimum solution, and its evaluated value. So with this, these are the two inputs that are taken. These are the few inputs that has to be given to the algorithm. So now we will write the procedure in a simplified manner. Step 1, you have to define the function df search and the input arguments. So since we have to start from the top node, so you can see that means the level it should be 1, and always you have to access the first element. So you can see our explanation in the previous slide. So each value you have to take the first value, that means you have to go from left hand side. So b should be equal to 1. So first branch only you have to go. Okay, that's what. So for this algorithm I will try to simplify the steps so that you will understand. So when it comes to your implementation, you need to implement with a few more steps. So I will write the main steps. Okay, and step 2, so first what you will do means, so I will write if. So actually you can see this algorithm. So you have to repeat the process, you have to traverse, you have to visit each variable, that means each node, and within each node you have to take the first branch. This procedure has to be repeated until you reach the leaf node. So if you observe this, you are calling the same function again and again, you can see the green mark, but with a different variable. Okay, with a different variable. So when you have to stop this process means when the level L1, L2, L3, L4. So therefore, since if L minus 1 is equal to D, so that means the procedure has to be stopped at L4. Okay, so what you have to do means you write one condition. Okay, you write one condition stating the if with the help of if statement. If the level L minus 1 equal to D, that means you reach the leaf solution. Once you reach the leaf solution, what you have to do means, that means you can see from this diagram, once you reach the leaf solution, you can see the leaf solution, you have to apply the function. Okay, that is an important step you have to do. Evaluate, that means you have to apply the function. Apply the function fun on capital X. So and then it will give you the solution. So for simplicity I am writing a SOL, solution comma its evaluated value. So when you are applying the function on that X, it will give you the best solution. Okay, that's what we are assuming here. You can write the step 4 function also. So you compare, I will write in sentence, compare with the previous evaluated value and store the best value. Okay, so I have written for your simplicity. And then in step 5 you have to make sure this, you have to return this one. Okay, return the list. Okay, return the list containing the objects of solution is equal to solution, and then evaluation is equal to, for a change I will write B evaluated, and then here I will write B solution just for a difference. B solution. Okay, so I am returning the list object contains of best solution and the best evaluated value. Okay, so I am simplifying for you, and finally step 6. So if I already told you now, if this is not leaf node, what you have to do means you have to check the input variable and take the leftmost branch. Okay, leftmost branch. Okay, so that means you have to call this function with a different value. So that we have to do. So that means if it is not a leaf node, what you have to do? Else. Step 7. You have to access each variable one by one. Okay, each variable one by one. J equal to 1 to the length of, so in our language we are having the list vector, so we are using that data structure. Domain of, so here the first index refers to, here the first index refers to the level, okay, first refers to the variable, and then in the step 8 what you have to do means you have to take the value present in that variable and store it in the corresponding indexing location, that is a J is equal to, you need to access domain L J. Once you perform this, that means we are collecting the what we are doing in this step means, you can see my previous slide, we are collecting the values in the path. We are collecting the values in the path and you are storing it in the X vector. Okay, say for example, if you are traversing along the left hand side or the first path, you have to store the values in this correctly positions. That is what here the meaning is. So once after storing it, immediately you are calling the same function. So you better call the same function. So you can use a CALL call DF search algorithm. So it is a, we are using the recursive algorithm. Now this time with increased level, that means L plus 1. So you are going deeper into the tree actually. Okay, so each level corresponds to one variable. Okay, so what you have to do is L plus 1 we have put. After that J you have to transfer, and the domain is same. The domain is same, and the function is also save. That's it. So once you are done with this, that's it. You can stop the process. So the algorithm you can stop. So you can write end for loop, and then you can put end if loop also here. End if loop, if condition, if is a condition statement, end if, and finally in the step 12 you can stop the process or function. End function. So for more understanding, I will draw the lines so that you will understand where is the indent. This if corresponds to this else, and this corresponds to this one, and these two are inside the for loop. So now you will have a better understanding. All the above statements are present in this function, so that now you will get a clear idea what is happening. I hope you understand. So in this way you can write the algorithm for depth first full search algorithm. You have to write neatly. So what we are doing means, the process is simple. We are visiting each variable one time. That too, we are taking the first value. Whenever we are having another set of new variables, just we are going traversing to that. So it is like visiting the node, and if it is having the children, and you are again visiting the children node, this process is repeated until you reach the leaf node. When you reach the leaf node, you construct the solution, intermediate solution, and compute the objective function, and if there is any previous value, you compare it and store the best value. Okay, store the best value. So after computing it, you need to perform the backtracking. That is taken care by the this recursive function. Thank you, students.